Video introduction. My name is Jason Welsh, and this is the ATtiny 85 video. And what has happened here is there's been some hard times lately about programming the ATtiny 85. If you search the internet, you'll find a very, very lengthy discussion everywhere about programming them with the Arduino. Okay, so I'll get into that, but first let me introduce the ATtiny 85. This is a very small chip you can get at SparkFun for $2.88. You can get it just about anywhere, but the ATtiny 85 is a very nice small form factor. This is running off 3 volts, an LED, and this thing will probably run several weeks. I have one that has 4 LEDs. They're blue, and it also looks for the calculation of light. So if I go like this over the top of a photoresistor, it'll turn on the LED. That's at work, and it runs 2 weeks without even recharging the 2 AAA batteries. That's awesome. So small form factor, very low draw, and it holds your Arduino sketch. But now, we used to be able to program these with the Arduino as the ISP, and now I also started getting into programming them using an external programmer. So I'm going to show you what that looks like, because really now that's pretty amazing, and I'll go into it in the video, but I will never go back to using these as ISPs anymore. In fact, I don't know if you can even use the Leonardo as an ISP, but I know you can use the Uno as an ISP, as long as you have the right chip installed on the Uno. Alright, so let's go into the next section of the video where I'll explain some more. Small form factor, blinky LED. You had me at that. If this is a familiar sight to you, you are in the right place. This is an ATtiny 85 chip, and that is a 10 UF capacitor set between the reset and 5 volts. Up until recently, I had programmed a lot of these chips, and then it stopped working. The only thing that changed in the equation was I had bought another Arduino, and then nothing looked different between the old Arduino and the new Arduino, except for the chip. So this chip right here is amply labeled P-PU. Okay, so the P-PU is significantly different than the P, and if you have the P.PU, it is a really uphill battle to now program the ATtiny 85 chip. Now you can do some voodoo, and I've heard placed on the internet where you could change a couple values in your AVR dude config. All pretty much failed. But here's the happy story. You know, the headache of this really was quite a headache, only because I was too cheap to go out and buy a programmer. And then once I had a programmer, I was like, wow, I will never ever program another Atmel chip ever in my life with the Arduino as an ISP. So this is my adventures of using a programmer to program the ATtiny 85 chip, and kind of a documentary of the sort to what hardware I had to go buy or configure in order to make that happen. Alright, so I hope you enjoy the ride. Let's go on to the next section. Alright, so you have a couple options here. We have option 1 and option 2. There's a lot of other options. I'll save you the hassle of going out and looking at all the options, but I will say that the other options, in my humble opinion, wean down to price and brand loyalty. Okay, so you can get places like SparkFun or Adafruit. They have these things, or You can look for other variations of them, but here's what I like about these two products. This one, the ZeptoProg II, has a little bit more options on it than the ever so popular AVR ISP MK2. Okay, the AVR ISP MK2 is $34 and the ZeptoProg II is only $22. What stayed my hand from buying it immediately was the fact that in your Arduino software, under Programmer, you have AVR ISP MK2, but you do not have anything that's called ZeptoProg II. Then, reading the manual thoroughly before buying, I found out that this emulates an AVR ISP MK2, so I bought it. And what's really nice is if you're into oscilloscopes, this has a software-hardware variation of an oscilloscope built into it that you can analyze your circuitry. Ooh! So it's a programmer, an oscilloscope. It does the ATtiny series Atmels, and it also does PICs, and it has serial RX and TX interface. Pretty cool. So bought it and got it and was totally frustrated with it for the longest of time, and pretty much figured that it was practically useless. Put it up on the shelf and never touched it again. Then come to find out that when I had the ATtiny 85 problem come up, I was like, oh wait, I have this programmer. And I took it back off the shelf and looked at it thoroughly and figured it out. And now I will never go back. It's pretty cool. So now the adventures of making this thing work, the ZeptoProg II hardware chip programmer. Alright, so let's continue. Alright, so we're going to need a couple things. One, you're going to need the programmer. I would also highly suggest that you get an extra long header with 6 pins. You find yourself this. It's a standard Arduino header. This is also the 6-pin variety. You get yourself the cable that it comes with the programmer. Okay. The red indicates pin 1. Then translate it back to this. Okay, so in this case I took these wires, or the headers off, and clipped them, so that way I can attach the ribbon cable to it. This made it very breadboard friendly and very universal. Okay, let's take this for example. If I wanted to adapt this to a breadboard, I can just simply slide the header in and bam, I can attach it to now a breadboard. So it's the all-in-one universal cable. If I wanted to translate it back, I would make another cable just like this, and then I could attach them together via another header just like this. So I like that idea, having things very universal, so I can plug them into a great deal of different projects. Okay, sweet. So maybe a good idea to make 2 of these cables. Alright, you're also going to need a small breadboard at first. And you can see that header. I just slid it right in. Okay. Now let's look at the pin out variation for this and see how it works. Because when you look at this type of pin, you may think it's pin 1, 2, 3, 4, 5, 6 or something in that nature. Okay, so here is the pin out. Here's pin 1, and you'll see pin 1, 2, 3, 4, 5, and 6. That's how it lays out. 1, 2, 3, 4, 5, and 6. Now, if you look at the data sheet, which is probably easier to jump in through here, you'll see that it's also labeled here 1, 2, 3, 4, 5, and 6, but it's not in the order that you might think it is, and it's not really labeled all that well here. Also, on the bottom of the device, you'll see it labeled. A little bit less. There we go. Love that camera. Right there. Again, pretty hard to read. So cross-reference all three of them and you should be fine. So while this is zoomed in, let's look at the breadboard and try to get these wires down pat. So I have this pointer, aka PLA spike from 3D printing. Alright, so if I got pin 1 right here, we'll start at pin 1 here. And so pin 1 is connected to pin 5. Okay, and pin 2 on the header is connected to pin 8. And I could keep continuing to do this, but you know, as an artist, I like to draw out things. So here's what the pinout looks like in Adobe Illustrator. So pin 1 is miso, and you can attach it to, here's pin 1, 2, 3, 4, 5, and 6. Okay, and these are all color coded, so just kind of watch that part and just pause it and make your connections. Also, I have provided the ATtiny 84 variation along with this. I'll try to include this document, which has a schematic that you can use to make your own PCB for it. Okay, and I'll show you how to make one of those in later lessons. They are kind of cool. I don't use any fancy things. I use a Sharpie marker and the copper plate you use from Radio Shack. Turns out quite well every time. And lends to the artistic touch, I think. Alright, so once you get that all connected and put in there, let's look at this. All you do is attach it here, like that, and then you attach this to the B side, which is, if you looked down on this, just like this. Also, you need to include a jumper. So I have a jumper here. Now, I looked all over the place. I used to have billions of jumpers, right? They used to be popular when we had IDE drives. Of course, trying to find a jumper nowadays is pretty pathetic. So what I did is I took one of the old headers, crossed over the pins on 2 of the slots, and then soldered them together, and thereby making a jumper. Okay, that jumper allows 5 volts to travel out of your USB into the chip, powering the chip so it can be programmed. On the top left edge here is pin 1 of the chip on this breadboard, which is, if you're new to that also, I will say that it's indicated with a dot up in the upper left hand side. That is always pin 1. Okay. Alright, so now we have everything kind of figured out, version of the breadboard and how to hook it up. The road isn't done, so let's go into making the Zepto 2 work with AVR and Arduino. Alright, now I'm going to show you the process of installing this beast onto your Windows 7 machine. Note that you'll need at least one Windows machine to get it started, and then you can use it on your Mac. So you have to configure it on your Windows machine, and then it works quite well Mac-wise. Which was kind of a turn-off, but that's okay. I'm well versed in both realms. There is a list of good stuff in here. So you find yourself the matairtech.com, and this is where the Zepto programmer lives. You can just type in ZeptoProg II inside any window and you'll find it. Okay, and you can see all the different things it does. Wow, no wonder I bought this thing, right? Awesome stuff. Lots of buttons, lots of whistles, and it has a nice Java interface. Okay, so let's go down a little further and find all the software that you need. First off, you'll need this one right here, this driver. You'll also need the application downloaded. But before you download or install any of this, install AVR Studio first. Okay, install that first. Then I would highly suggest you restart your system. And then, before you launch any of the other crazy stuff, let's go down. Way down here. So the order of operations is definitely not in any order of the documentation. We're going way down here. Right here. So download the ZeptoProg II firmware and download Flip. Okay. The firmware should be a hex file that you need to put somewhere on your system. And then Flip, once you install it, you'll have this fancy little thing located right here. Flip 3.47. Looks like this. We're going to update this beast before we even use it. That is a key. Alright. Now, it will scream for drivers. Like anytime you plug it in, it'll say, wow, I don't have any drivers, I don't have anything. Once you get Flip and the other installed, the ATml Studio, those two provide a lot of drivers for it. So let's install the drivers, then update it, then program with it. So let's continue. Alright, so the system works like this. There's buttons on this thing, and the first button on this side is program mode or tool mode. Okay, and if you don't push anything, you'll go into a bootloader mode. So let's load the drivers for all three of these to get started. So you take your Zepto programmer and you hold this side, the program button, down as you insert it into your USB drive. If you did it correctly, one light on the bottom should be lit and the other one pulsating. And depending if you have the jumper installed, it will pulsate fast, and if it is off, it pulsates slow. Okay. Now, in your Windows control panel, hardware, system and security, device manager, it should have something in here under Jungo. Okay, you'll see that loaded. If you see the AVR ISP MK2, you installed the AVR Studio correctly, and it loaded the drivers for that program mode. Good. Let's go into the other mode. So in this case, let's take it out of the USB drive, hold down Tool button, and insert it. Okay, let's look back at Device Manager. This time you'll have a USB Serial Communication Class Abstract Control Model, COM20 or COM whatever. The way to test this one out, we have to load the tools. Okay, and here's how you load the tools. There's a jar file right here. Just download that one. And if you have Java installed, which I hope you do, the Java runtime environment needs to be installed. Once you have the Java runtime environment installed, or JRE, you can run jar files. So just search JRE or java.com to get the java.com installed on your system so you can run jars. You see executable jar file. If you double click on this, it'll bring you in the land of wonder, and it'll show a COM port. You choose the COM port 20 and hit connect. You should be able to connect to this beast. Once you are connected, head over to hardware configuration and change it to an AVR programmer by default mode. And then make sure it's on AVR Dude. This will allow you to use it with the Arduino interface. And last thing I put is recover mode enabled. Okay, then you can just update your EEPROM on it, and it'll write those changes to it. So now anytime you insert this thing with no buttons pushed, it will automatically go into AVR programmer mode, which is nice because I don't want to think about that. And you can match any of the other settings down here below with mine. Alright, now you can exit out. Now with that installed, we have one last driver to install and to check, and that is the bootloader, so we can update it. Alright, so lastly we have program mode, which has its own separate driver. What you need to do is find in the documentation where it says AVR ISP MK2 compatible programmer. It's on page 7. What you do is you'll take the device out of your USB drive and then press both buttons, push it in, and this will go into programmer mode or bootloader mode. In bootloader mode, you can update it. It'll come up with something that looks a lot like library USB Win32 devices, and it'll say ATmega 32U2. If it does not pop up with this, what you do is there is driver. You update your driver, browse, and the program that you downloaded was Flip, and you installed it already, hopefully. It's under Program Files 86, and if you page down to Atmel, then Flip 47, USB, and depending if you have a 64-bit operating system or 86 processor, you can go here. I have the 64-bit and hit OK, and it'll update that driver. So it should now say ATmega 32U2. Also, if you have problems, you might have to install this. Okay, that's only if you have problems though. I didn't have problems. It worked out quite well. Now, with that in there, let's go to Flip. You should also have that hex file that I told you to download. So click on the chip. You want a Mega 32U2. Hit OK. Then read it from your USB. Open. Make sure you uncheck blank check and uncheck verify. Load hex file. And you load the hex file that you downloaded. I'll just load mine to show you that it's not scary, because, you know, things like this scare people. Oh, to actually save this, you right click on it and you save link as. And make sure you put period HEX after it. I'll save that to my desktop. And then I'll go back over to my flip. Load hex file. I'll load that in. And I'll hit run. That's it. You've now updated it to the latest firmware. Now you might want to check its configuration, because if you update it, right, it stands to figure that it might override some of the properties of it, and it changes a few things like does it still work in AVR Dude. So go back to the executable jar file, head over to hardware configuration, and notice that it doesn't show up. Why? Well, remember, you have to load it in tool mode. So unplug it, click the A side, which is the right hand side of it, plug it back in, hit refresh. You now have COM20 that you can connect to, and now you'll see that it's still loaded with the same things. Good. Once you get over that fact that you have to press buttons to insert the stupid thing, you'll be alright. Alright, believe it or not, we are now ready to program with it, and we will never have to do this again. But I have it documented just in case I forget it now. Ooh. So, let's program with this bad boy and see what happens. Alright, so we're going to need a library for the Arduino software. If you go to github.com, that's github.com, and type in ATtiny into a search, you'll come across Demelis ATtiny. Now, to give credit to Demelis, which is really David A. Mellis, developed the ATtiny variation for the software for Arduino. So if you go here, you'll be able to download the master zip file by clicking this, hit save, and save it to your desktop. Okay, so once that's downloaded, we can extract it, go to it, go into it, and find ATtiny. Copy that, and it doesn't matter what variation of software for Arduino you use. I'm using 1.1, but you can use 1.03 and 1.05 depending what you want. It doesn't really matter. That's what's nice about having a programmer. You don't have to jump between these too much. Now you can put this in one of two places. I myself like to put it inside the software, but if you put it in, let's say, documents, if you have one of these, an Arduino folder, you'll have a hardware folder, and you can stick it right there. Now it will affect any of the Arduino software that you use with this set to be your sketch folder. Another way you can install this is go to C drive, go to Program 86, go to the Arduino that you're using, go to hardware, and then you could also put it in here if you wanted to. But I prefer it to be in the documents folder, that way it affects all. So if you're in your software, what you do is you go to File Preferences and make sure that's your sketch folder. You'll know that you have it correct if you go to Tools and you go to Board and you have a whole bunch of new boards showing up. Okay, in this case I have the ATtiny 85 with the internal 8 megahertz clock. It can go up to 20 megahertz if you have an external crystal on it, but then you're going to lose 2 of the I/O pins. So the 8 megahertz, I really had no qualm about that. Really, it's fast enough for most applications, unless you're dealing with maybe audio or some kind of very, very arduous stuff. But the 8 megahertz runs quite well. If you don't see this, you just have to restart your Arduino software. And I'm using 1.01 here. Alright, let's load up an example. I like the blink, and I also like putting that on 0. Okay, so let's go back to visual aids, right? Okay, there's only in the ATtiny 85 chip. This one right here is pin 0, 1, 2, and I believe this one's 3 and 4. Okay, good. And if you want a better breakdown of that, I would go to David's website, which can be found here. High to low technology. If you page down, here's a good breakdown of it. So pin 0 and 1 are the pulse width modulation pins. Alright, so if that's on 0, you should now be able to make sure that one's on internal A. The serial port doesn't matter. Notice that the programmer doesn't show up on a serial port, but you have to go down to Programmer and go to AVR ISP MK2. And then what I like to do is just go like that to compile the sketch. And then I like going File, Upload using Programmer. This is especially handy if you have another microcontroller hooked up on your system, which I do. You can see that there's an Uno on COM7. Alright, look at that. No errors whatsoever. Perfect. Alright, now I have to go get a USB cord in order to show you what just happened. So, I'll be back. Alright, so after programming it, we can play with it. So here's where it was sitting, inside the little breadboard cradle that I used to flash it. I'll put that off to the side. We got a fresh new breadboard. And I have a couple really old batteries that I haven't charged up in a while. Okay, so it represents 3 volts, but really hardly any milliamps whatsoever because they're batteries and they're half dead. So the odds of blowing this LED out is very rare. Very, very rare. Just make sure that, if you're not using half dead batteries, you'll have to use a resistor on the LED. So what I'm going to do is hook up the negative to this, which is under pin 4. The positive, which is on pin 8. and install my LED, which is the negative is going to be the shortest lead on this, and the positive one is going to go onto pin 5. And there we have our blinking LED. Boop. So a really small Arduino project fitting on an ATtiny 85 with minimal amount of power, and it runs for a very freaking long time. Like even with these half-dead batteries, I've had a project that has gone a week with LEDs, like 4 or 5 of them, in series with each other, and it still runs like clockwork. I have to charge the batteries maybe every other week. It's really cool. So minimal amount of power, it still does its function. You notice it blinks a little slower, and because that it's 8 megahertz, it will blink a little bit slower. To counter it, you can just lower this to a different value. So watch those delays. The delays are costly when it comes down to the amount of kilobytes that this thing holds. Okay, lots of delays equal lots of kilobytes, and then yeah, I would keep those at a low value. Alright, so I hope you enjoyed the how to program an ATtiny 85 using a programmer like the Zepto II. Enjoy.